Hey guys, it's Mrs. Dugan. Happy whatever day it is. I've lost count and lost track of it. So just a little heads up what's going on. Mr. Dugan went back to the hospital on Tuesday night. He was admitted to the hospital just for some observation, and I'm not sure when he will be out, hopefully by this weekend. So with that being said, I'm going to teach you from here. We're going to go over our kinetic energy notes today. So everyone needs to have the paper from the green basket, or the sub has given you this paper, okay? This needs to get glued in. You can glue it in at the end so that you can get all this written down. But we're going to go through this just like what we did with the potential energy notes. I'm going to talk and you're going to fill in. So since we're online, I'm going to go through the PowerPoint and they're just going to pop up like what we've done sometimes before. So again, you need to make sure that you have all these notes written down. Okay, when I come back, you never know if we're going to have a quiz. All right, a notes quiz. So make sure that you have this written down. That was a hint. That was a hint. Sorry, I had something in my throat. All right, so today we're going to talk about kinetic energy. Now, we talked about potential energy. Potential energy is half of the equation, and potential energy is energy it's stored energy. Now, what potential energy can turn into for 7th grade, okay, is that it turns into kinetic energy. And kinetic energy is energy due to motion. So this is anytime something is moving. Right now my head has kinetic energy. My hands, we all know I talk with my hands a lot, so those have kinetic energy as well. But first things first, we're going to go across your page. So this is coming straight from your notes and we're going to fill them in. What is kinetic energy? Well, kinetic energy is energy due to motion. Okay, we've written that down a couple times now. Energy due to motion. Anything in motion is going to be kinetic energy. And like all forms of energy, we are going to be using the unit joules, or J, okay? Do not call it J's, remember, it is joules, all right? It's written weird, but it's an easy word. Now, when we talked about potential energy, we said that there were two things that impacted potential energy significantly, and that was mass and height. Now, kinetic energy is similar, but we have one very important thing. The first thing is that we have mass. Mass doesn't ever change. If you have more mass, then you're going to have more kinetic energy because you're able to do more work. It takes more work to get that moving. As a reminder, work is the transfer of energy from one object to another in order for it to move, or and transferring energy into something else so a force is acting on it. So the other one, if you think about kinetic energy, we have energy due to motion. Okay, motion means that we're going to have velocity. Remember, velocity is how fast something is going in a certain direction. So if I have my water bottle and it's traveling like this, that means that it is traveling, let's say 1 meter per second to the right. Okay, so that is velocity. So if I ever were to ask you, what are the two things that affect kinetic energy? You would say mass and, say it aloud, velocity, okay? Or say it under your breath, all right? So two things that affect kinetic energy, mass and velocity. Moving into the relationship. So what's the relationship between mass and kinetic energy? Well, if you think about it, I just told you, if you have more mass, then you're going to increase your kinetic energy. I have this spray bottle, okay, and I have my very, very heavy water bottle. If I throw these, which one is going to require more energy to move? The really heavy water bottle. And that means that more energy is transferred into this water bottle as it's moving forward. So we are going to have more mass. As mass increases, kinetic energy is going to increase as well. All right? So it's a positive relationship. Repeat after me. As mass increases, please do it. Humor the sub. As mass increases, kinetic energy increases. Okay? One more time. As mass increases, kinetic energy increases. All right? Hopefully, I asked the sub to Write down if you did it or not, because maybe you get some bonus points. But okay, as mass increases, kinetic energy increases. Both thumbs up because they're both really good. All right, so now we have an example. Which would have more kinetic energy if they were traveling at the same speed, and why? So we have a bowling ball and a paper ball. I do not own a bowling ball, but let's get the point. Bowling balls are usually about, sometimes they're 8 to 12 pounds. But we're going to pretend they're kilograms, okay? So 8 to 12 kilograms. Then a paper ball is going to be less than a kilogram. So which one is going to have more kinetic energy? Well, the bowling ball. And why does it have more? Because more mass means that there's more energy. It has more energy because this is a proportional relationship. Remember, proportional or direct relationship? When one goes up, the other goes up. As mass increases, kinetic energy increases. Moving on, what is the relationship between kinetic energy and velocity? What do you think? Show me with your fingers. What do you think? Is it going to increase? If we increase our velocity, what's going to happen to kinetic energy? Is it going to increase or decrease? Do it. Don't be lame. All right, so if you did increase, you are correct. However, it's going to increase by a power of 2, and I'm going to show you why in a second, okay? So when we increase velocity, that means that our kinetic energy is going to increase even more. It's an exponent, okay? So as we increase velocity, everybody repeat after me. As we increase velocity, we increase kinetic energy. So let's do that again. As we increase velocity, we increase kinetic energy. So kinetic energy is going to shoot up super fast, and I'm going to show you that in just a second. All right? Now, the reason why it increases by a power of 2 is because when we are trying to solve for kinetic energy, we are going to square the velocity, meaning we go velocity times velocity. All right, so remember, like 2 to the second power, or 2 squared is 4. 10 squared is 100. We're multiplying it by itself. Now we're going to look here. Jose throws a ball at 45 meters per second, and the same ball again at 60 meters per second. Which velocity has more kinetic energy, and why? Well, we know from up here, if we increase velocity, the one that has more, then we are going to increase our kinetic energy. So that means that, let me move my face so that you can actually see this, okay? That means that 60 meters per second is going to be more. And the reason why is the more velocity means that it has more kinetic energy. And this is because it's an exponential relationship. So that's a new type of relationship, and we're going to talk about it in just a second. So if you're like, I have no idea what exponential even looks like, we're going to see it. You're going to graph it, okay? So the things that we need to know right now is, 1, the relationship between mass and kinetic energy. As we increase mass, kinetic energy rises the same. However, when we look at our relationship between kinetic and velocity, we increase velocity, kinetic energy rises up even more. So if you were to ask yourself, okay, which variable has more say in kinetic energy, which one do you think it is? Do you think it's velocity, or do you think it's mass? Okay, I want you to do sign language. So velocity or mass, which one is more impactful? Which one matters more? If you held up V for velocity, then you are correct. And that's because you're multiplying it by itself. All right. And again, when I get back next week, hopefully fingers, toes, eyes, they're already crossed. All right. Hopefully when I get back, we'll be able to really dive into this and see it too. Now, moving on to the next one. This is where we are going to start kind of graphing. I'm going to give you some visuals to see what it looks like on a couple different ways, okay? So first things first, the relationship between kinetic energy and mass is a proportional or a direct relationship, all right? That means as one goes up, the other goes up. That's it, all right? So when we look at this, let's say we had a tennis ball and we had our baseball. So our tennis ball has a mass of 58 grams, and the speed is 145 kilometers per hour. That's really fast, by the way. All right. So if we have that, then, okay, what does that look like? What does it look like on let's pretend it's like the skate park. We've done the skate park. It's like one of those little bar graphs, okay? So which one is going to be higher, the tennis ball that has a mass of 58 grams or the baseball that has a mass of 145 grams? Well, obviously, the mass with the ball with the more mass is going to have more kinetic energy. And when we graph mass compared to kinetic energy, this is what we're going to get. We're going to get a nice straight linear line, all right? Because as one goes up, the other goes up. That's all we have. It's a proportional relationship. It's not complicated. Now, when we go over to our velocity, this is where it gets a little tricky when we get to graph it, okay? But when we look at this, we know that more velocity means that we're going to have more kinetic energy. So if we have a baseball player throwing a baseball at 100 that has a mass of 140 grams, but at one point it's going 74 kilometers per hour, and the other time it's going 90, well, which one is going to have more kinetic energy? Think about our relationships. What is the relationship between velocity and kinetic energy? Well, when we have velocity, if we increase our velocity, what happens to our kinetic energy? It skyrockets. And when it skyrockets, it's going to be what's called a exponential relationship. So when we use our little bar graphs, we can see that the one that's not going as that has less velocity, it's going to have less kinetic energy. And when we actually graph this on a line graph, this is what we get. So you can see that we are going to build our velocity. Our velocity is going to skyrocket. Our kinetic energy is going to skyrocket as we get faster. Okay? And again, I'm going to show you the mathematical. What I need you to understand is that both of those mass and velocity are going to increase kinetic energy. All right? However, velocity is much more important than mass. And this is why. We have this equation. Let me move myself again. I feel like I'm standing in front of the board. Okay, this is our equation. K equals 1/2 mass times velocity. Okay, so if we look at mass, this is only 1 m, all right? But this is velocity to the second power. Doing that means that you're taking your velocity and multiplying it again by the same velocity, all right? However, we have 1/2, we have 1/2 in front of mass. Mass isn't as important, okay? It's not going to grow as fast. Now, let's get into our what these mean. K. You're going to either see K or KE, and that's going to stand for kinetic energy. And our kinetic energy is always measured in what? Joules. Okay, for 7th grade. Then M. We already know what M stands for, and that is mass. All right, that's mass, and that's always in kilograms. And finally, we have velocity. And velocity is meters per second squared. Okay? So what I'm trying to tell you right now is that we are working with 2 halves of an equation. When you think of kinetic energy, right, it's 1/2. The other half of this is potential energy. And when we add them together, we're going to get the total amount of mechanical energy. When I get back, we're going to dive into how to calculate kinetic and potential energy, and we're going to talk about the relationship between the two. Because guess what? As kinetic energy increases, potential energy is going to decrease. As potential energy increases, we've got less kinetic energy. Okay? All right, so what you're going to do next, make sure that you have read the board. Make sure all of these things are filled out. If you missed some, I've actually put this PowerPoint on Schoology so you can flip through that. But after this, you need to work on the sort. The kinetic and potential energy sort is super fast, okay? Do not cut the paper. Don't cut the paper. You're going to write in the scenarios. We're not cutting. I didn't want to do that with and put everyone into a mess and all of a sudden you didn't get it done. All right, but you are going to write down the scenarios and determine if they're kinetic or potential energy. All right, guys, I hope that everyone has a great day, and hopefully I'll see you next week or tomorrow. I'm not sure. It just depends on how Mr. Dugan is doing. All right, so just remember, stay curious.